Good afternoon, everyone, and welcome to CMP225. Sorry, it seems a little loud. I'm Art Baudo. I'm a Principal Product Marketing Manager in the EC2 Core Group here today. And I'm here today with Martin Yip, who will also be presenting with me. Martin, why don't you introduce yourself?
Yeah, hi, everyone. So happy to be here today. So excited to be back in person, back on stage. So I lead EC2 product marketing for compute as well as networking. I'm happy to be here and interact with everyone today.
All right, so we're going to kind of go back and forth a little bit throughout the deck, try to make it interesting. And if we have a little bit of time, I'll give time for some questions at the end, if we can do it. Just a note, to my left, your right here, there's a microphone. If you could step up to the microphone. If we don't happen to have enough time for recording, Martin and I will make ourselves available. There is another session in the room afterwards, so we'll do it outside right after if we run out of time to get through this. So today, our plan is to cover some of the last 12 months or so of launches and other information that we've had with EC2, try to demystify some of EC2 for everybody, and talk about directionally where we've gone, and a little bit about how we have developed EC2. So I'd like to start with this little thing here, the light bulb. Our goal in EC2 is actually to make EC2 as simple in the cloud as flipping a light switch, to make it easy for you. And hopefully by the end of the talk today, I'll help have demystified a little bit of EC2 enough so that we can all agree that it is something that is pretty easy. So I want to start with a couple of stats to kind of talk about the global breadth of Amazon and EC2. So to date, more than 30 billion instances have been launched in Amazon EC2 since we launched back in 2006. This is an incredible number of instances that have launched. And that speaks to the breadth of the network that we have to devise, the reliability that's needed, and I'll talk to how we have done that so far. Everything we have done has been built upon what we call the Cloud Pillars, something that was here that we started with on day one, if you had ever taken a look at Jeff Barr's 2006 blog. Those two things were, we want to provide you, our customers, with the tools and services to securely and reliably work in the cloud. And the second is to provide you with the best possible performance at the lowest cost. I'm going to talk about how Amazon has designed our system to be able to do that. We're going to finish today's talk with a little discussion about cost, because I think in today's current macroeconomic climate, everybody's interested in, you have to pay for this stuff. How do you do it in a cost-efficient manner as well? So the next thing, for those who attended or heard Dave Brown's the VP for EC2, and he says to me all the time, sometimes the small things make a big difference. And our focus on some of those small things, it's actually led to so many of the innovations that I'm going to talk about today. I'm going to talk a little bit about what those small things are that we've paid attention to that actually resulted in the creation of some of our own silicon, why we started that path. And I hope to invite you on that journey as well today. So far today, we have roughly 100 million EC2 instances are launched per day at Amazon. If you had come here in 2021, the number I would have had on the screen last year was 60 million instances. So this gives an idea about the rate of increase that has happened here at Amazon EC2. And I'm going to share to you today some of the stories about how we have disrupted and revolutionized the compute paradigm. One of the other things I have is we actually even have the patent for defining the cloud and defining the actual virtual CPU that we use today that's out there. Those 100 million instances, incidentally, correspond to roughly 700 instances are launched in Amazon EC2 per second around the world. And just another note is that in 2022, customers launched 5 times as many instances that they did in 2018, talking about how many instances our customers have used here. So to summarize a little bit about where we're going with the talk, we're going to talk about that global scale. I'm going to talk about the innovations of Nitro and the Nitro system itself. Martin's going to come up here and talk a little bit more about some of the compute instances and the new introductions we've had. And then I'll come back up and talk a little bit more about cost again. So as a reminder, we celebrated our 16th anniversary this year in August of 2022. And this represents a portfolio of the regions that we have had. In our first 10 years, we introduced 11 regions. Today, we have 30 regions that have launched, including one just 2 weeks ago in Hyderabad. We have 5 other announced regions, and we have 96 availability zones. Amazon, as a cloud provider, has the most availability zones, and most of our regions have a minimum of 3 availability zones in them. Why do I talk about that? This talks to the reliability and our focus on providing reliable and available services all the time. So this is like having multiple data centers within those regions. But these regions are spread throughout the globe, and our customers have variations of where they need that performance. And in many cases, you want to have the performance even closer. So we introduced local zones. So we announced that we would have an additional 30 local zones that we were going to add in 2021. We've already begun that process to the original 17. So today we have 25 local zones spanning the globe. And what these local zones do is allow AWS Compute to get even closer. These local zones are spread through many major cities throughout the globe. And this is an effort, especially if you have applications that are perhaps you're streaming video or you're doing gaming, the local zones allow us to provide closer connections to customers that are out there. And in addition to local zones, we have now also offered AWS Outposts. Outposts are our vision of being able to deliver compute to many customers, even in an on-premise fashion. Outposts are something that we can deploy in 1U to 42U racks. And that means that we can provide essentially an entire data center on-premise if needed, or we can actually include something within an IoT situation in on-premise as well as needed. And what this does is this helps reduce the cost that it takes to work with the cloud. These outposts are fully managed by AWS, and they allow customers, such as yourselves, the opportunity to actually use one group of APIs when managing the cloud and also managing content that is placed in the on-premise environment. Some of the customers that are currently using Outposts are pretty wide and varied here. They talk about customers in many different industries. I'll also mention that earlier we had NASDAQ on stage with Dave talking about how they have actually leveraged many of these different places using both local zones and our Outpost premises in order to do the entire financial network here in the AWS cloud. So why AWS infrastructure? Our infrastructure comprises everything from routers, load balancers, custom servers and semiconductors, to our own custom software and silicon. But all of this is designed and purpose-built for the cloud and designed and developed by AWS. It's all unique to us. And then the question customers and other people ask me all the time is why do all of this stuff yourself? Why not take off-the-shelf components? The answer is we started to realize that by designing the servers ourselves, we can improve the overall reliability. If the problem happens in the server, then we can handle it and fix it very quickly without having to rely on a third party. And that was a small thing, that fix in reliability, that resulted in us realizing that we could expand that to other spaces as well. 10 years ago, we introduced our load balancers, which are the heart of being able to make sure that we can optimize the performance and balance the equipment between different servers within our data centers. We introduced our own custom software, our hypervisor, which I'll talk a little bit more about, which helps make sure that lightweight hypervisor does not consume any of the CPU resources, allowing us to provide higher performance than competitors into the cloud. Just this week, we announced that we have actually over 600 instances. Amazon Web Services, we offer more instances than any other cloud provider. But this 600 number, people sometimes will tell me there are a lot of instances. That creates a lot of confusion. But I would say that the instances are actually very tailored. And you can really narrow down the instances to the salient few that are important to your workloads. So if we take each of these here and start taking about the categories and choose the category. So for example, let's say you need a general purpose workload. Perhaps you're doing a web service or hosting web services. You take a look at the general purpose workloads, and then you look at maybe the processor type in the second capabilities category. Perhaps you need to do the work on x86, or maybe you're flexible and you can use our ARM architecture. Now you've further narrowed what you need to do down to a handful of instances, AMD or Intel in the case of x86, or the ARM being the Graviton processors. And finally, you can choose if you're going to use a managed service, further narrowing it down. So every time you choose the workloads, that 600 list gets shrunk down to the ones that are most important for you. And these are the building blocks that we believe that everyone can work off of and how we have designed our network. Back in 2006, we had one instance, the M1. The M1 instance came with 1 gigabyte of networking that was available, which at the time we thought was really, really impressive. But since then, we realized that customers don't need just a one-size-fits-all instance, and that wasn't really practical for us. So we introduced general purpose, which are those M instance types. We then did compute optimized. We then began offering memory optimized. And then we added our accelerated computing, which concludes our FPGAs, our GPUs, the machine learning platforms, and we also added storage optimized instances as well. So we've tried to break that down. And what maybe unknown fact is you can actually still access the M1 instances should you decide you wanted to deploy these to this day in our cloud system. And we also even have a class on how you can use all of our older instances. We have not deprecated a single instance since our launch in 2006. So customers can take a look at all of it. So what is this innovation pace? I put this chart up. I didn't go all the way back to 2006 here. We start in 2010. And you can see the various kind of milestones, if you will. And you can see that accelerating platform here. I want to just call out a couple of things. One, our introduction Inferentia 2, which Martin will talk a little bit more about. That's happening in 2023. But I also want to call out 2 other items, Graviton back in 2018, and the fact that we've actually introduced 3 generations of Graviton since that introduction in 2018. But if you think about the pace of silicon innovation, that's pretty rapid. And also, this innovation of the Nitro System, which is where the acceleration of our instances began. What is that Nitro System? It's more than this pretty picture. But this pretty picture gives me a great idea of the architecture, or myself, an idea of the architecture that we've designed here. The Nitro System is unique to Amazon. But what the Nitro System has allowed us to do is actually develop all of these instances even faster and deploy them faster for you. The other thing about the Nitro System is focusing on this has allowed us to deliver better performance to customers that are here. So the Nitro System produces and provides an overall performance benefit to customers at a component level performance. And how do I show that performance level? This is a chart here. So stage to the far right of the slides here, your left, is just a standard information about using benchmark just as SpecInt here. So basic compute information. And most cloud providers have roughly the same performance there. However, if you look to the right to what I would characterize as real-world workloads, you can see the variation starts to be pretty significant, especially if you look at Redis. We have a 27% advantage versus some cloud providers, or Memcache, where we have up to 22%. So all in all, using Amazon Web Services, we believe you have about a 15% better performance simply by using the Amazon Web Services. And that's the equivalent of almost a full generation of CPU performance just by coming here. So why are we able to do that? Part of that is that Nitro System. I have offloaded a ton of function that many other people have to place into the CPU. That allows me to provide more performance. Just as a note about this data, this is based on our 6th generation instances, which were launched just in 2022. So this is a direct comparison here for the Ice Lake processor on the x86 side. So why build your own chips? So these chips allow us to do specialization. It allows me to provide specialized security to the platform. It allows me to better and faster deliver things. As I said, since Graviton launched in 2018, we've delivered 3 generations of a processor. This is an incredible pace of innovation in the silicon space. And it allows us to deliver on other innovations. We'll talk about the Nitro SSDs, and also talk about Graviton as we get there as well. And finally, this is core of our security as well. We believe at Amazon that we are not interested in touching or viewing any of customer data. Your data and your workloads and the security of them are our biggest priority. I cannot, and no operator at Amazon can physically access any of your workloads or your data. This is core to how we have done this, to move this off there. I'm going to talk briefly about security as we go forward. But the Nitro System, as I mentioned before, isn't just one thing. It's a combination of our cards, which here allow us to do VPC networking, our EBS services, storage, and controller. And they also deliver a security chip to us. Just as we power on, security is very, very important. As we boot up our system every day, or anytime we do a reboot, we do cryptographic attestation on here to verify the images on there. If there's ever a problem with the images in the system, we do not boot and we rectify. But keeping this away from customers such as yourself allows us to make updates and allows us to do these improvements without having a direct customer impact, including when we update software and the operating system and make these type of changes. And finally, that lightweight hypervisor, which allows us to better do and offer our scheduling of the instances. Excuse me. So first, I'm going to talk about networking here and what we've delivered. As I said earlier, back in 2006, we delivered 1 gigabit per second of networking, something we were pretty proud of. And then we made a pretty large leap back in 2019 to 25 gigabits, and now 50 gigabits in our networking performance. We introduced our network enhanced instances, and this year, earlier this week, we introduced that we now have network enhancements in our 6th generation up to 200 gigabits per second. I'll just call out the very large 1,600 gigabytes on the far right side and answer the question of where the heck is this and who uses this. This is in our machine learning space in the Trn1 area. So for folks doing Trainium, if you're doing machine learning workloads, in the last like 5 years or so, you've moved from doing and trying to do millions of models to billions. And you need this additional networking performance out there. So we'll talk a little bit about Trn1N as we go through here, but that's what's on the outside here. So this week we introduced our EC2 6th generation optimized instances. These offer, as I said, the 200 gigabytes per second, 200 gig in networking bandwidth. And that means that you can increase your data transfer from S3 by 2x, which is pretty cool. And these instances support up to 80 gigabytes of EBS bandwidth. So next, we introduced storage. So a lot of people, coming from a silicon background, I'm not sure I always consider storage silicon, but it's in the same relative family, I would say. But why would we start focusing on silicon? Everyone usually talks about performance on the CPU side of the house. But the reality is if you can't access the data that you're going to be doing something with, or the time it takes to access that data, or the latency that it takes, it becomes a performance problem as well. So we recognized this, and we introduced our Nitro SSDs before. Back in 2021 at reInvent, we started this path here with the Nitro SSDs. What this has done is offered us the ability to provide 60% lower I/O latency performance and up to 70% reduction in latency variability. Two key elements when you access in SSDs. Our SSDs are also encrypted with AES 256 encryption as well. So earlier this year, we introduced i4i, which is our first storage instance using the x86 platform here. This uses Intel's Xeon Ice Lake performance, and we offer 30% better compute than the i3 performance that was here originally. We also have two other Graviton-based instances, the IM4GEN and the IS4GEN. So the difference between the two of them, aside from the slight name, is the memory to vCPU ratio that's here. So the IM4GN is a 1:4 vCPU to memory ratio, and the IS4GEN is a 1:6 vCPU ratio. So depending upon what you needed and what's there. But since then, since these introductions earlier this year, we haven't actually stopped there. Earlier this week, actually yesterday, we introduced torn write protection here. This has been enabled off of our Nitro SSDs for the i4i storage here. And what this does is an innovation that we've delivered for all of our customers so that you can have, and we can reduce SLAs for customer workloads here as well to improve overall performance and security of these. We increase up to 30% better data transfer using the torn write protection, excuse me. I think there's no better way, though, to talk about this than to give a brief customer example. And I might mention Splunk was actually here yesterday talking about how they have used and leveraged these. But one key element about Splunk is they do a lot of data collection, and they have to analyze data and reports for their marketing reports really quickly. And so that's why I think it's a great example here. Using the Graviton 2, so the IS4 GEN instances, they've experienced almost a 50% better decrease in their search runtime performance here, which results in better productivity for customers here. So I talked a little bit about networking. We did storage. I'm going to finish here talking about security. So today, Amazon is trusted by millions of customers around the world for providing protection and data services. And it's key to that. So a lot of people in this industry call this confidential computing. But I think the definition, there is no real dictionary or Webster's definition of confidential computing and what it is. So I'm going to offer our take on confidential computing here. We see confidential computing as something falling into two dimensions. The first dimension of confidential computing is to protect data of the cloud provider, which is pictured here. That's us. So we want to protect your data from us. The second dimension here that comes up is potentially protecting data within a customer. Perhaps you have two entities that you may need to isolate, and you want to protect personal data. Think about an example I have that we published a blog with the Trade Desk. This is they were using UID2, which is you may never have heard of UID2, but I'm sure everybody in the room has at least accepted a cookie once or twice on their browser. UID 2.0 is a version to be able to protect your personal information using this. So be able to provide you still a customized ad. Sorry, everybody needs to get a customized ad to pay for things, but without having to exchange too much personal information. So that's a great example of dimension number 2, which we'll talk about using here. We introduced Nitro Enclaves in 2020. We introduced Nitro Enclaves 2 years ago, and I'll talk about that briefly. So our security, earlier this year, we did Nitro TPM, which is the introduction of Trusted Platform Module in EC2. So you can now use this to protect secrets or keys and other sensitive data on EC2. So going back to the second dimension, protecting the other data that you have. So Nitro Enclaves provides fully isolated, secure environments to be able to do development and testing. We introduced these Nitro Enclaves, as I mentioned, 2 years ago, in order to solve problems customers had come to us about talking, particularly about personal data that you wanted to protect. They're hardened, constrained environments that can only be accessed, as I said here, through a local shell. Then in the last 2 months, we've introduced 2 new features associated with Nitro Enclaves. One, Nitro Enclaves are now available on Graviton. And Dave Brown announced earlier that we now also offer Nitro Enclaves in Kubernetes. So from your Kubernetes pod, you can also launch an enclave as well. So further enhancing our features here. Next, I'd like to have Martin come up here. And Martin's going to start talking a little bit about where we are going and some of the instances we introduced from the x86 and the ARM platform. Martin?
Thanks, Art. And hello, everyone, again. Excited to be here. So as Art had mentioned, AWS offers the broadest and deepest choice for our customers. Why do we do this? It's important for customers to be able to tailor their infrastructure to their workload needs. And part of that is offering customers choice in terms of processor across Intel, AMD, and AWS. Let's dive into Intel first. So Intel has been with AWS from the very beginning. Back in 2006, the M1 instance that Art talked about, they were with us powering that instance. And since then, we've grown our partnership, and now we have over 350 instances together, spanning every single compute category and every single region. Art had mentioned earlier about the network optimized instances that we launched earlier this week, but I really want to dive into some of the other instances that we have launched earlier this year. So the Amazon EC2 C6ID, M6ID, and R6ID instances are, these are our 6th generation disk variants of the core instances that are powered by 3rd generation Intel Xeon Scalable processor, aka Ice Lake, and come equipped with NVMe attached storage. They come equipped with up to 7.6 terabytes of the local NVMe storage, and delivers up to 15% better price performance over comparable previous generation instances. It's not just about the storage, though. It's also about faster processing and faster networking, right? It's really, with each generation, we try to offer customers more in terms of performance and price performance. So with these instances, they offer 2x faster networking and 20% higher memory bandwidth than previous generations. They also come with support for the new total memory encryption that encrypts the memory of the instance itself. These instances, the main difference between CM and R, is, as Bart mentioned, is really the vCPU to memory ratio, whether you need compute optimized with a 1:2 ratio, general purpose with a 1:4 ratio, or memory optimized with a 1:8 ratio of vCPU to memory. So these workloads are, these instances are ideal for your general core compute workloads, including things like enterprise workloads, databases, back-end and front-end servers, as well as many other things, but specifically those that need additional access to high-speed, low-latency storage. And as you know, at AWS, we don't stop innovating. We've also announced earlier this week that we are introducing the 4th generation of Intel Xeon Scalable processors into our portfolio, and the first instance to have that is going to be Amazon EC2 R7iz instances. These instances are both high frequency and memory optimized instances. Again, they're powered by the 4th generation Intel Xeon Scalable processor, aka Sapphire Rapids. They'll have up to 128 vCPUs with 1 terabyte of memory, and that results in 2.6x more vCPUs and compute versus previous generation instances. 20% higher memory bandwidth, as well as these are going to be the first x86 instances to have DDR5 memory. So, that means just much faster memory overall, and 2.4x higher memory bandwidth. As I said, these are high frequency instances, so they're really designed for things like EDA workloads or databases that have high per core licensing, or gaming that requires just really big, beefy instances. So we look forward to delivering these in 2023, coming up. Next, let's dive a little bit into AMD. So AMD has been a great partner. We were the first cloud provider to offer AMD in our portfolio back in 2018. And today we have over 100 instances with AMD. They span just about every category also. And they offer better economics in terms of you get the performance that you need, but at a 10% discount versus other comparable x86 instances. Let's dive into some of the instances that we launched this year with AMD. So earlier this year, we launched the 6th generation compute optimized, general purpose, and memory optimized C6a, M6a, and R6a instances. These, again, are kind of the core compute instances that are the workhorses of your portfolio. They're powered by 3rd generation AMD EPYC processors with up to 192 vCPUs, up to 100 or 1.5 terabytes of memory, and 50 gigabits per second of networking, and also 40 gigabits per second of EBS bandwidth. Depending on the instances, they offer significant performance improvements over previous generation, 35% better performance improvement for the M6a and R6a. That's mostly because we're doing a 2-generation jump from the 1st generation Naples processor to the Milan processor, and with the Compute Optimizer, we're jumping from Rome to Milan. So you're getting a 15% price performance jump there. Offer a lot faster networking, 2.5x faster networking, and up to 2x faster EBS bandwidth. So you're going to be able to transfer data, make transactions to and from EBS a lot faster. And as I said, they're great performance, but you get also the 10% lower cost versus other x86 instances out there. Now let's talk about AWS and the Graviton processor. So one thing Art talked about earlier was Nitro, right? And with Nitro, we actually got a lot of experience building ARM hardware as well as building software for the ARM ecosystem. And we really took that experience and applied it towards building our own ARM-based processor, the Graviton processor. We launched our first Graviton processor in 2018, And customers loved it, but they wanted more. So we offered them the Graviton 2 processor a year later. Today, Graviton 2 base instances, we have over 100 Graviton 2 base instances across every single category. And these Graviton instances are great in the sense that they offer 40% better price performance over x86 base instances. So just for that effort in terms of just migrating over, you're getting a significant price performance improvement. But customers wanted more. They liked the power, they liked the cost benefits of Graviton 2, but they wanted even more performance. So last year at re:Invent, we announced Graviton 3 processors, and earlier this year we delivered the first instance, the C7G, based on Graviton 3. Graviton 3 processors are 25% higher performance than Graviton 2 processors, so they offer a lot more performance that you would need. They also offer the 2x higher floating point performance for things like your compute-intensive workloads. They were the first instance in the cloud to offer DDR5 memory, which, as I mentioned earlier, offers that really big boost in terms of memory bandwidth performance, 50% more memory bandwidth performance, and perhaps most importantly, they're really sustainable in terms of just being carbon friendly. They use 60% less energy. Both Graviton 2 and Graviton 3 actually use 60% less energy for the same performance than other comparable CPUs out there. So really, really important to a lot of companies, just being able to get that performance, cost, but also being good to the environment as well. So I mentioned the C7G earlier, but let's dive a little bit deeper into this. C7G is the first instance that's powered by Graviton 3 instances. They offer the best price performance for compute-intensive workloads in the EC2 portfolio, with up to 64 vCPUs and 128 gigabytes of memory, 30 gigabits per second of network performance, and 25 gigabits per second of EBS performance. As I mentioned before, because they're powered by Graviton 3, they get that 25% extra performance and 2x higher floating point performance. And really, they're great for your compute-intensive workloads. And then earlier this week, we also announced a network-optimized version of the C7G. These are great for not just compute-intensive workloads, but workloads that are compute-intensive, but also network-intensive. They are built using the new version of the Nitro card, so you get up to 200 gigabits per second of network bandwidth and up to 50% higher packet processing performance. So really great in terms of data transfers to and from EBS as well as S3 and other data-intensive activities. And because they're built on Graviton, you get that same Graviton performance benefit that I mentioned earlier. Really great for network-intensive workloads, things like network virtual appliances, analytics, and even CPU-based machine learning. So customers love Graviton. Today we have customers across all industries, from startups to enterprises, all sectors. We have over 40,000 customers actually using Graviton, so quite significant growth over the 4 years since Graviton was first introduced. Let me dive a little bit into some of these customer stories. So Epic Games, they're the makers of the Unreal Engine, as well as games like Fortnite and Gears of War. They use Graviton for their game engines and found that Graviton was very suitable for the demanding latency-sensitive workloads. And they also, while being able to run massive multiplayer gaming, they're able to also get that significant price performance benefit. Formula One, perhaps the world's most prestigious and well-known motor racing competition series, uses Graviton for their computational fluid dynamics workloads to help them really model how their race cars will drive in various kind of wind and air dynamics simulations, so that they can basically produce a better race car and a better performing race car. And then Honeycomb.io, they're the maker of an observability platform, has gone all in on Graviton. Liz Fong-Jones, actually, when she used Graviton 2 and the Graviton 3, she thought it was just sorcery how easy it was to migrate to Graviton and get all that performance and cost benefit. And speaking of that, we talk a lot about performance and cost, but really the third pillar of benefit is just the ease of migration. One of the things that we did from day one with Graviton was just make sure that the partners were ready. So we worked a lot with partners, including all the Linux operating systems, the ISVs, and the open source softwares to make sure that they were ready to run and support Graviton at launch. And we've been really successful with that as the community has grown. Today, as I said, all the major Linux operating systems, development tools, and open source software support Graviton. So we're really happy just to see that adoption out there. And speaking of Graviton, it's not just about the Graviton instances, which you might be familiar with, but it's also about managed services. Whether you want to do it yourself with Graviton-based instances or AWS managed services like RDES and Elasticache and Neptune and EMR and more, you can do that and get the same price performance benefit with Graviton. Earlier this year, actually, at Silicon Innovation Day, we had announced the Graviton Fast Start program, which makes it easier for you to migrate over to Graviton, whether it's EC2 instances or managed services, and get that great performance and price performance benefit. We've seen customers use Lambda and migrate over to Graviton and get that benefit in as little as 4 hours. So it's a really quick and easy way to start adopting Graviton. So that's a lot of choice for our customers. But there's actually one more partner that we have not spoken about yet, and that partner is Apple. So not too long ago, we began working with Apple to enable Mac workloads on the AWS EC2 platform. We introduced the first Mac instances in 2020, 2 years ago, and they feature Mac OS and Mac Mini hardware. And the ease of use, the cost benefit of pay-as-you-go, and all the tools of AWS. And customers loved the experience, but they wanted more. So earlier this year, we actually announced the EC2 M1 Mac instances that are powered by Apple Silicon, the M1 chip. And this is offered for the first time in AWS. So the M1 chip integrates the CPU, GPU, neural engines, and I/O, and much more into a single chip. With the M1 Mac instance, you get improved performance, actually 4x better performance for things like builds and things like that, compared to the x86-based Mac instances. And yet you still get all the benefits in terms of security, reliability, and the ability to connect with other AWS services and use other AWS services. So customer feedback since we launched this has just been amazing, and obviously we're going to do more in the future. So when we started off on this cloud journey, we had talked a lot about breadth and depth, and being able to support every single workload. Excuse me. But there was one workload that we thought it's really difficult to support: high performance computing. High performance computing was one of those workloads that people thought could never be run in the cloud because it's so compute intensive. It's not only requires compute, but a lot of storage, a lot of memory, fast networks, and things like that. And HPC, it's used to tackle some of the world's biggest challenges, from drug discovery to genomics to energy utilization and much more. And customers have tried HPC on AWS, and they've been very successful, though. Customers like Formula One, as mentioned earlier, AstraZeneca, Lawrence Livermore Laboratories, have partnered with AWS to solve some of the toughest challenges on the cloud. We've worked for many years making sure that HPC workloads run well on AWS. We've built services like Batch that help you run hundreds of thousands of computing jobs in the cloud, or AWS Parallel Clusters, which is an open source cluster management tool that lets you automatically set up the required resources for HPC workloads. elastic fabric adapter that allows you to scale your applications to thousands of CPUs and GPUs and run distributed applications. And also Amazon FSx for Lustre that provides you a fully managed shared storage for scalability and performance. But customers, really wanted and needed the EC2 instances to be HPC optimized as well. So, they were telling us that you can't create a performant, cost-effective foundation for HPC without the HPC optimized instances. So over the years, we have built many of the EC2 instances that are capable of running HPC workloads. Just earlier this year, we announced HPC 6a that are based on the AMD, the third generation AMD EPYC processor that offers 65% better price performance for HPC. We have C7G and C6i and C6a, but customers, they want more. So I was happy this week that we announced HPC 6ID. Now, HPC 6ID addresses another kind of HPC workload, whereas HPC 6a addresses compute-intensive workload. HPC 6ID addresses HPC workloads that are more memory and data-intensive. They offer 600 gigabit of EFA networking, so you get much faster networking. You get much better price performance, well, 2.2 times better price performance for data-intensive HPC workloads. And this is really targeted towards, as I said, that new kind of workload, the memory and data-intensive workload, things like finite element analysis that require modeling of the performance of complex structures like wind turbines and concrete buildings and industrial equipment. HPC instances are just really designed to deliver that leading price performance for those data and memory intensive HPC applications. So these HPC 6ID instances are powered by third generation Intel Xeon Scalable processors and deliver the best price performance for this category of workload. They're really ideal for those tightly coupled HPC applications. They deliver the best per vCPU compute and memory performance for those applications. We also announced another HPC instance this week, which is the HPC 7G instance. These are the first instances that are powered by Graviton-based processor. And actually, they include a new type of Graviton processor, a new version of it called the Graviton 3E. Now, what these Graviton 3E processors does is they remove the performance limits of Graviton 3 to unlock performance that includes 35% better vector processing performance, which is great for HPC applications that really depend on that vector, that actually does a lot of that vector instruction performance or processing. And these HPC 7G instances, they're ideal for yet another type of HPC workloads. We had compute intensive, we had data and memory intensive, and now these are geared towards both compute and network intensive workloads. So they come with the 5th generation Nitro cards that Art had talked about earlier. They offer 200 gigabit per second of EFA network for really fast transfers as well. Just a couple of weeks ago when we were at the supercomputing conference, SC, we were honored to win for the 5th year in a row the HPC Wired Best HPC Cloud Platform Award that really just identifies us as being able to offer this platform that helps a lot of the HPC the companies running HPC workloads out there. So this marks the 5th year in a row that we've won this award, and we're really honored to have that. Just to transition a little bit, talked about generalized compute. I've talked about HPC, but now let's transition and talk about another category of workloads that's also very compute intensive. Let's talk about machine learning. As with processors, we offer the broadest choice of accelerators as well. We offer FPGAs from Xilinx and GPUs from NVIDIA and AMD, and we offer our own custom accelerators as well with Trainium and Inferentia. As workloads become more demanding, the need for acceleration with these accelerators is increasing across the board. Now, machine learning is a powerful technology that's becoming very ubiquitous everywhere. You think about machine learning, there's kind of two main aspects of machine learning. One is the training, which is all about building those models, creating the models. And then there's inference. That's where you use those models to generate predictions based on input. Every year, we have over 30,000 customers now build, train, and deploy their machine learning applications using Amazon EC2 infrastructure services. And on the training side, we have instances with powerful GPUs like the P3s and P4s. We also partner with Intel last year to offer their Habana Gaudi processors in the DL1 instance. On the inference side, we have G4s and G5s powered by NVIDIA GPUs that really help with that inference. But as ML became ubiquitous, ML models really became large and complex, and they're growing exponentially in size. These larger and complex models result in a rising cost of compute. Just think about 3 years ago, the state-of-the-art machine learning models were perhaps 100 million parameters in size. Today, those same models, or the models that are coming out today, have grown to be hundreds of billions of parameters in size. So that's a multi-100x increase in size, which is tremendous, but also scary because that's a lot of input. This growth in model size is expanding the time to train the models from days to weeks, and sometimes even months, because they're so big and so complex now. So AWS noticed this trend, and we started developing our own ML chips as well. We took our experience from developing Graviton processor, and we thought, okay, why don't we apply it towards the ML side? So a couple months ago, we announced the Amazon EC2 Trn1 instances, which are powered by AWS Trinium processors. These are the highest performance and lowest cost for training deep learning models in EC2. They're powered by 16 Trinium accelerators with up to 512 gigabytes of high bandwidth memory, along with 800 gigabit per second of throughput, so you could do your distributed machine learning training. TR1, as I said, is the first instance with 800 gigabit of networking performance, but they also support native machine learning frameworks like PyTorch and TensorFlow, so that it becomes easier for customers who are already doing machine learning to kind of adapt their models to Trainium. We're not stopping there. As Art had alluded to, we are just not clicking. Oops. So as Art had alluded to, we're actually going to come out with a network optimized version of the Trainium chip that's going to offer even faster networking, 1600 gigabit per second of networking that will speed up training times even further. This is incredible what developers are going to be able to do to train these ultra large models to gain greater efficiency, just faster training times. On the flip side, we also, a couple years ago, we announced EC2 Inf1 instances. Once you've trained your models, you then have to use those models and provide input and ultimately make inferences. And these inferences require quite a bit of performance to generate predictions in real time. And that's why we really built the Trn1 instances. They're basically, we wanted to offer this ability to have to deliver low latency as well as low cost of inference for customers. Inf1 is great for small and medium-sized complexity, but as I said before, these models are growing much, much bigger. So that's why earlier this week we announced the Inferentia 2 processor that'll be able to handle much bigger size models, actually 100 parameter plus models actually. So now you can use training and inference from AWS with Trainium and Inferentia to handle these really large, ultra complex models. Inferentia 2 will deliver up to 4x the throughput and 10x the lower latency, just 1/10 the latency of what Inferentia 1 delivers today. So you're going to be able to have those real-time predictions and inference really, really quick. They offer up to 12 Inferentia 2 accelerators and up to 384 gigabytes of high bandwidth memory so that you can have really fast inference. They will also, just like Inferentia 1, they'll be integrated with PyTorch and TensorFlow, so you can really have an easy time with running your models in Inferentia. And just like Graviton, we really focus on sustainability here. So one thing I'm happy to say also is that these Inferentia 2 chips, they're going to be offering 45% better performance per watt than the GPU-based instances. So again, we always look for offering performance, lower cost, but also trying to be as green as possible. So we've seen customers of all sizes adopt Graviton. Why don't we just dive into some of these stories? So Autodesk uses Inferentia for their Autodesk Virtual Agent, or AVA. This is basically a chatbot that answers over 100,000 customer questions per month by applying natural language understanding and deep learning techniques to extract the content, intent, and meaning behind queries. With Inferentia, Autodesk was able to get 4.9 times higher throughput than the GPU-based instances. So tremendous improvement in terms of just the speed at which you're able to react to questions that are coming in. Anthem created applications that automate the generation of actionable insights from customers with deep learning, natural language models. With Inferentia, they were able to get 2x higher throughput to GPU-based instances. So just tremendous amount of improvement in the with using Inferentia. And finally, Airbnb, they were able to see a 2x improvement in throughput right out of the box by switching over to Inferentia from their GPU-based instances for BERT models and PyTorch, using PyTorch. So just a tremendous amount of speed gained and lowering of cost by switching over to Inferentia. With that, I'll switch over to Art, and he'll talk about cost optimization.
Thanks, Martin. So we're going to wrap up today by talking a little bit about cost optimization. I'll probably have a couple minutes for a few questions. But I think that as we talked about all of this today, and Martin talked about all of the instances we have, I think that the final thing is everything costs money to do it. So how do we do this so that we can actually help you save some dollars here? And so we offer a large number of instances. So as we talked about before, we offer x86 platform. We also offer Graviton. But within x86, we offer two different types, the Intel and AMD instances. And even within that, you get a 10% discount. But also, if you use the instances in different low-cost geos, you can save even further on that. So there's instant savings. And then there's the further savings, as Martin mentioned, with Graviton, that you can save about 40% or so using the Graviton-based instances if you can do your workloads in ARM. So then we also offer a series of purchase options. On demand, which is our base purchase model. And we also offer spot, where you can get a discount where you use our extra capacity up. And then we also offer savings plans as well. And then we deliver tools to everybody to try to save and provide recommendations. Those tools, such as Cost Optimizer, can give you a recommendation or where to use another instance without reducing any performance, but also getting better cost. So what do those savings models look like? As I mentioned before, it's on demand is our baseline here. Savings plans, which require a commitment to us for you to get a discount. Sthowever, with that, you get substantial savings. And finally, spot instances. And since I really didn't want to end today without any final statistics, just want to close with a handful of things here. So right now, using savings plans, customers, since we introduced our savings plans in 2019, customers have saved over $15 billion by using the savings plans. So this is a pretty large amount of money that can be saved if you sign up here. The other thing is since we started the spot instances, customers have actually saved $10 billion in the last 5 years. Actually, at dinner last night, I was talking to somebody, a Japanese customer of ours, who was sitting there, and he discovered that between 1 a.m. and 5 a.m. in our office, in our region in Tokyo, that there is plenty of spot capacity, and his instances can be automatically programmed to run between 1 and 5, and they don't mind a little bit of disruption here or there. And so if you're in that category, there's an easy way to take advantage at either odd hours or using alternative regions, a really great way to save a lot of money as well using spot. So Dave Brown likes to show this chart, which means I like to show this chart as well since I work for him. But here, we can show you how we think your kind of configuration should be baseline. So at the bottom here in the pink is the savings plans. So if you have a lot of, as much of the work that you have that's steady state, you can list it and put in a savings plan to save money on it. Then occasionally there's work that you need in that on-demand bucket. Costs a little bit more, but it was something you couldn't have prepared out years or months in advance for. And then finally, for workloads that you have that are in that can afford some interruption, you can use spot instances to save money on that. A great example of that is potentially if you're doing payroll for your company. Payroll is something that's going to come out, let's say, twice a month. It doesn't have to happen all on Thursday afternoon. If you pace it out, it could be interrupted over time, just as long as you achieve the goal of delivering pay to the employees every 2 weeks or what have you. But in the meantime, you could save yourself a lot of money during that calculation. So my final stat today, before we close, is we have, since we introduced Compute Optimizer, we have offered 10 billion recommendations. This includes recommendations for a little over 80% of EC2 usage that has been out there. So this is an easy way, and I highly encourage everybody to save it. In a different presentation that I gave last year on cost savings, I brought up and showed how to use Compute Optimizer. But everyone has access to Compute Optimizer, and it's based off of real data that is offered to you, the customers, based off of your data. So it's not random data. It's based upon your data usage patterns that is delivered to you. So we do an optimization for you based off your EC2 inferences. We're a huge data company. Martin just talked all of this stuff about machine learning. We use that ourselves to provide these recommendations to you. And that is the key for our success. And we also offer AWS support resources as well when you use Compute Optimizer. So I just want to thank all of you for coming out here today. I want to thank everybody for coming to reInvent. If you have any questions, I'm happy to take them here. You can step up to the mic over here on my left side, your right side of the room. Otherwise, I just want to say thanks.